everyone, welcome to today's tutorial. We're giving out a chemistry content in this channel. So you can either follow us on this Instagram page or you can follow us on the YouTube channel, the same name, Best Science Brain. So this tutorial is meant for those in SS3, Senior Secondary School 3, High School 3, or for those who are in their first year of higher institution. You can follow us, as I said, on YouTube, Best Science Brain, where you can subscribe to watch many of our videos. On this Instagram, where we're doing some short practicals. What we have today is qualitative inorganic analysis. Qualitative inorganic analysis. We're trying to identify cations. Cations are positive ions found in salts. For instance, we have a salt. This is a salt. Sodium chloride is a salt. So when this salt ionizes in water, it breaks into sodium ion and chloride ion. So this positive ion is called a cation. Another example of a salt is copper sulfate. When it ionizes in water, it gives you copper 2 ion and SO4 ion. Copper 2 is also another cation. So we're looking at the test for cations. How can we identify a cation? If you're given an unknown salt, how do you know the cation or the positive ion present in that salt? Our test today will be based on using ammonia to identify cations. Identify cations using aqueous ammonia. So if you're a student or you're a teacher, you can subscribe to our YouTube channel or you can follow us on this Instagram. In our YouTube, we have many videos, many tutorial videos, so you can go to the YouTube and subscribe and also follow us on this Instagram. A salt and a non-salt, you can see it having a blue color. This salt, can call it S or non-salt. We want to find out the cation present in this salt by testing it with aqueous ammonia. So how do we go about it? We don't use solids on ammonia. We have to first of all dissolve this salt inside water. Dissolve inside water, we have to fix a funnel here on this place and then pour distilled water into this salt and dissolve it first. So the amount of water here is much. So we have it. So this is water. We then have to stir the container to make sure that the salt dissolves completely. So having done that, we can have a kind of, we shake it vigorously to aid the dissolution process. So we have formed a solution of the salt, almost soluble in water. So we want to find out the cation that is present in this salt using aqueous ammonia. What do? I'm going to collect or get a clean test tube. I'm going to get a clean test tube, and then from this test tube, from this solution I have obtained here, I'm going to take a small sample of this solution, a little amount. So that is okay for the test. Then we're adding ammonia to this salt. So this is our ammonia. How do we test? How do we carry the experiment? We add ammonia in a drop of this into this place. To get the drop exactly, I'm going to use a dropping pipette to collect 1 or 2 drops. I'll press the rubber end, so we have a drop has entered. So if you look at the brim of this, you're going to have a gel-like solid formed. That gel-like solid form is blue in color, pale blue. It's called pale blue precipitate. So the word precipitate means a solid form when 2 solutions are added together. So when we added ammonia in drops, we produce a pale blue precipitate, although we are still slightly deep blue up. So if you look at it very well, have a pale blue precipitate form inside the test tube. Then we're going to add this ammonia in excess. Look at ammonia and adding more of it into this. You can see that the color has changed and that blue jelly substance has disappeared. We're now having a deep blue solution. A deep blue solution. So how then do we report our work? We'll go to the whiteboard. We'll now say S, which is the name we give to that salt. The salt that was dissolved before, we'll call it S. Unknown salt, aqueous, because it's dissolved in water. We're not testing the salt, we're testing the solution. Plus ammonia, aqueous ammonia in drops. When we added in drops, what did we observe? We observed a pale blue gelatinous precipitate formed. And when this was formed, we now added ammonia again, and that line will say plus ammonia, aqueous ammonia in excess. When we did that, we obtained, we now say that we saw that the pale blue gelatinous precipitate dissolved to give a deep blue solution. To give a deep blue solution, as you can see here, a deep blue solution. So what kind of ion will give us this? The cation that is there is copper 2. It's right, copper 2 ion present. Then after adding the SS, we write copper 2 ion confirmed. So briefly, take a look at our test as we go to the next experiment. Experiment now, we're having another salt solution. We call this salt D, unknown salt. You see, it's already dissolved in water, colorless inside water. And then we're going to do a test on this salt to know the cation inside it using aqueous ammonia. We are taking 2 cm cube of the salt already. That is a small amount of the salt. We'll now go to our test table. Then to do that, we're going to bring ammonia. Again, we use a dropping pipette and take 2 cm cube of ammonia and then add 1 or 2 drops inside it. So if you look at it, you see a kind of cloudy appearance, gelic, somehow white. But we call this white precipitate. White, gelatinous, not pure white. White gelatinous precipitate. Now I'm going to add the ammonia in excess to this to see whether it's going to dissolve or not. So I'm going to add extra ammonia to see whether that white solid will disappear. So adding, you see it disappearing little by little. So when you look at it, nothing is remaining inside again. So the white gelatinous precipitate had dissolved, giving us a colorless solution. So let us report our work. To report our work here, all added in drops, we have white gelatinous precipitate formed. In excess, we say precipitate dissolved to give a colorless solution. Now the cations that will give us white gelatinous precipitate, we will add ammonia in drops, are only 2, zinc 2 ion, or we say comma, not and, or aluminium, that comma means or, aluminium 3 ion present. The in excess, one of them will dissolve out of this. We are suspecting 2 inside this salt we are tested. So the one that will dissolve in excess is only zinc. When I say zinc 2 ion confirmed. Had it been that remained insoluble, we have said aluminium ion present. So the cation that inside this solution is zinc 2 ion dissolved in excess of aqueous ammonia. So we remain connected as we go to the next test. Okay, Now we are holding another unknown salt, which is also colorless in solution like the one we did previously. Let's call this unknown salt E. So we are trying to find the cation present or the metal present in this salt solution. So this represents a little quantity or 2 cm cube of this solution. So we're going to do the test on this solution. This is a sample obtained from this solution. We are calling this solution E. Then, using aqueous ammonia, we're going to add 2 drops of ammonia, few drops of ammonia into this solution. This is ammonia. Using the dropping pipette, I'll collect some ammonia and then add few drops inside it. So you're going to see what is happening there. You see, this is white. So examine the white very well. This white is chalky. It's different from the white we observed when we did the previous test, the test on D. That white was gelatinous, but this white is chalky in appearance. Chalky. There is difference between that one was gel, while this is chalky white formed here. So we're going to add more ammonia into the chalky white solid, which is called a precipitate formed, and see what will happen. We're adding more ammonia in excess. You see that it remains insoluble. It is still chalky or white in color. Chalky or white in color. So we'll now go to the board. So which cation? So we added in drops to this E aqueous. We obtain white or chalky precipitate formed. The cation that gives us this white precipitate is lead. Right, lead 2 ion present. In excess, you can see, look at the part is now. This is the sediment is going down, showing that it's insoluble. So in excess, we say white or chalky precipitate remained insoluble or did not dissolve, remained insoluble. So we now say lead 2 ion again, present or confirmed. So that is the test for lead 2 ion in the particular salt sample. So go through our work as we go to the next experiment. We have our final solution today for today's tutorial. This is solution F, unknown, call it F, also a colorless solution. We want to find the cation present in this salt. Already, this is 2 cm cube of a representative sample. This represents this. We obtained this 2 cm cube from this F solution. So we're going to add ammonia to know the cation that is present inside 2 cm cube of this. So we're going to bring in ammonia. This is ammonia solution. Using the drum pipette to collect 2 drops. We're going to add it into this. So watch the bottom. At the bottom, we added ammonia. That nothing happened. So no solid is formed. So no precipitate is formed. We say in chemistry, there is no visible reaction. We're now adding the ammonia in excess to this. We added ammonia in excess. Also, nothing appeared to have happened. No visible reaction taking place. We now go to the board in drops. Here I will say no visible reaction. Or you can write no precipitate formed. It is wrong to write no reaction. You must put the word visible, showing that you did not see anything. There could be a reaction, but you didn't observe it. So we say no visible reaction or no precipitate formed. In essence, the same no visible reaction, or we can say in bracket no precipitate formed. So on our inference, we now write calcium 2 ion present, then calcium 2 ion confirmed for this test. So we wind up our lesson for today. Today we have learned something, haven't you? Haven't you? So we have learned how to identify some cations in chemistry, how to identify copper 2, how to identify lead 2, how to identify zinc 2, and calcium 2. Are using aqueous ammonia. So follow us on YouTube, Best Science Brain, YouTube. We are going to have tutorial, full tutorial or full package on chemistry, physics, and further mathematics. So remain connected always. Thank you.